All right, key concept. Step 1, when necessary, solve at least one equation for one of the variables. All right, so basically you are going to isolate one of the variables. Okay, whichever one looks easier to isolate. Could be the y, it could be the x, but you want to get x equals something or y equals something. All right. Step 2, substitute the resulting expression into the other equation by replacing the variable. And then solve that equation. Step 3, substitute the value from step 2 in the other equation, solve for the other variable. So you have to solve to get both variables, x equals some value and y equals some value. All right? So let's take a look at example 1. Substitution when there is one solution. One solution. So the first equation says y equals 5x minus 3. This has y isolated by itself. And y is equal to 5x minus 3. So wherever we see a y, we're going to put in 5x minus 3 in place of that y. All right? So I go to my second, the other equation, and I rewrite it as 3 times x minus 2y. Well, now I know y is equal to 5x minus 3, and I'm going to put that in parentheses. Okay? So, parentheses, 5x minus 3, that's my y value. I'm going to put that in a different color maybe, equals negative 8. Okay? So as I look at that equation where we substituted in for y, I need to do some distributing. That means I'm going to have to multiply. I have this negative 2 that I'm going to distribute with 5x and negative 2 with negative 3. So the first term's just going to stay the same. 3x and negative 2 times 5x is going to be negative 10x. And negative 2 times negative 3 is going to be plus 6. And that's equal to negative 8. Do you have your notes? Can I combine any like terms here? Yeah. I see 3x minus 10x. What is 3x minus 10x? Lens, what's 3x minus 10x? Negative 7, right? So that is negative 7x plus 6 equals negative 8. We're solving an equation, so I want to undo any addition or subtraction first. So just like a two-step problem or equation, subtract 6, and please try to do this vertically, okay? 6's cancel out. Negative 7x is equal to negative 8, and negative 6 is negative 14. Divide by negative 7, divide by negative 7, and x is equal to positive 2. That's the first part of my answer, because now I have to solve for y. So you are going to substitute this x equals 2 back in for x for one of these two equations. Now, the first one already has y by itself. So if I substitute this x equals 2 right here, it's going to give me y equals my answer very easily, right? So let's go back to equation 1 and say y equals, it's 5x minus 3, and I'm going to substitute that x equals 2 in place, or the 2 in place of the x. So 5 times 2 minus 3. Order of operations says I need to multiply these, so that's 10 minus 3. Y is equal to 7. So my solution is x equals 2, y equals 7. That is a point. That is an ordered pair. So my final answer should be to write it as an ordered pair of 2, 7. 2, 7. Okay? So if I have one solution like that, what must that tell me about these kind of lines? What kind of lines are these if I have one solution? Are they intersecting, parallel, or same line? No. If they're parallel, they wouldn't have any solution, right? Because they wouldn't cross at all. If I have one solution, they must be intersecting lines. Intersecting lines. Now, that's not part of this. That's just a little extra. Okay? Any questions on that? Let me take a look at the next few. All right, let's do... Let's try the first, number 1, down below. Says y equals 5x minus 10 and 2x plus 2y equals 124. For this first set of equations, this is called a system of equations. Again, we have y isolated. It is by itself on the left-hand side. So I'm going to substitute 5x minus 10 in place of y in the other equation. So I write the second equation, 2x plus 2y equals 124, and I'm going to substitute in for y. Y is 5x minus 10. Put that in parentheses because many times you're going to be distributing or something that you have to do with every term inside. So 5x minus 10 goes in parentheses, and then finish that equation, equals 124. And again, we are going to distribute that positive 2 with everything on the inside. So 2x stays the same. 2 times 5x is 10x. And 2 times negative 10 is negative 20 equals 124. And do I have any like terms? Yes. 2x plus 10x. Sherlyn, what does that give me? 2x plus 10x. 12x. Very good. 12x minus 20 equals 124. I need to add 20. We want to undo any addition or subtraction. Add 20. 20s cancel out. So 12x is equal to 144. 12x means I'm multiplying. You want to undo that multiplication. So you divide by 12. And x is equal to 12. And you're like, hey, I'm feeling pretty good. I've got x. Don't forget, you need to also find y. So if that is my x amount, okay, substitute it back in for either equation. Now, as you look at these, again, you have x. You want y. Y is already isolated here, so substitute 12 right here in place of this x. So I'm just going to do this right up here and say y equals 5x minus 10 y equals 5 times 12 minus 10. 5 times 12 is going to be 60. Minus 10 means y is equal to 50. Yeah, that's a big number. Bigger than what we usually deal with. And what's my final thing that I need to do now that I have my x value and my y value? Put it in as an ordered pair. Okay? So x is 12. Put your comma. Y is 50. So my solution is that ordered pair of 12, 50. So what kind of lines are these? They're intersecting lines again. And you know what? That's what most of these are going to be. I should say that's what most lines that you pick in general would be. We will try to give you some other ones. Let me see if I can figure some other ones. Any questions about that problem? All right, let me see here. These all look not too bad. Let me take a look at this. These all look pretty easy too. Let's go to number 5 at the top of the next page. Number 5 at the top of the next page. That would be at the top of page 9. It says x is equal to y minus 2 and 4x plus y is equal to 2. Once again, here we have one of our variables isolated. This time it is the x, and that's okay. It doesn't always have to be y. It can be x. So every time I see an x in the other equation, I'm going to substitute y minus 2 in place of that x. So 4x plus y equals 2. And then I'm going to substitute in that y minus 2. And then don't forget the rest of it. Plus y equals 2. Page 9, top of page 9. Is that there? Do you see it? Problem number 5. So now I am distributing again. Distributing that 4, which means I'm multiplying. 4 times y is 4y. 4 times negative 2 is negative 8. Plus y equals 2. Do I have any like terms? Yes. 4y plus y. There's a 1 in front of there that you can put in. 4y plus 1y, Allie, gives me 5y minus 8, good, equals 2. You want to undo any addition or subtraction, so let's add 8. Add 8. 5y is equal to 10. Divide by 5. So y is equal to 2. That's the first half. And again, x is already isolated. So take that amount, substitute it in. You're like, ooh, that one's not so bad. X is equal to y minus 2. X is equal to 2 minus 2. Yes, you should show it. So x is equal to 0. So final answer. What would my final answer be? Crystal? If I have x equals 0 and y equals 2, what would my final answer be? I have to put them together as an ordered pair. So that's going to be 0, 2. 0, comma 2. Again, make sure it's in parentheses. Everybody knows it's an ordered pair then. Okay? Questions on that? So we are doing this for 2 days. We are doing that first part, which is kind of the easier part, and then tomorrow we'll get into the second part and do a little bit of what looks like a word problem. So I'm going to give you some time now since I haven't gotten a lot of homework. We've got about just under 15 minutes. So I want you to be working on your homework 1 or homework 2, asking questions if you have questions. But I do want everybody to be working, okay? Any questions on what you should be doing right now? Okay. All right, so let's take out whatever you're going to work on. Homework 1, homework 2. You could even start on homework 3 now if you wanted. But yeah, let's get homework 1 done and in first. And if you've got questions, just ask. Yes, ma'am. Okay. So here, to write an equation, we want to put it in slope-intercept form. Okay? So where, and it doesn't matter which one you pick, but what is the y-intercept for one of those equations? 1. Okay, so keep that in mind. And maybe you can write it down. And that's a positive 1, so it's going to be plus 1, right? So from that plus 1, how do we get to another point? Did we go up and to the right or down and to the right? We went down 2 and over to the right 2. So what is negative 2 over or divided by 2? What does that simplify to be? So negative 2 divided by 2 is going to be negative 1, right? So you could also have gone down 1 over 1. And if you go down 3 over 3, they're all going to be negative 1. So that means your slope is negative 1. And then what do we always put after the slope?
1.
X. So negative 1, x, and in front of it, y equals. You could put over 1 if you want there. Okay, so let's try it for the second one. What is your y-intercept? Okay, positive, negative, good, good. And from that point, are you going up and to the right or down and to the right to get to another exact amount? Now, that's in the halfway point. We don't want to do that. There you go. If you went up 2 over 3, so what is that slope then? Up 2 over 3 is going to be 2 over 3. X. There you go. Does that make sense? Up 2 and then to the right 3 for 2/3 x. So the solution is where they intersect. And what is that point?
3.
3, negative 2? Is it negative? There you go. All right. Good. Anybody else need some help on that first one? Are we all needing some help with those equations maybe? Is that what yours is about too, Naima? Sorry. Okay.